Good day, ladies and gentlemen. My name is Katrina Washing, and I'll be giving feedback on my project design of microwave filters using transmission lines. The most important part when starting a project is the problem statement as well as the motivation for the project. Microwave frequencies come with unwanted noise, interference, and distortion. Therefore, it is important for a filter to be created in order to get rid of all the unwanted signals. Microwave filters are used most commonly in wireless communications, broadcast radio, as well as television. Without microwave filters, transmission signals will be filled with static, therefore making it so that the radio signals come out very distorted and the television signals come through with a lot of static. The benefits of using microwave filters are that they filter out undesired frequencies within the broadcast receivers. They reduce noise levels as well as oscillator leakage. They are easy to troubleshoot and they are smaller in size. In terms of the implementation of the solution, the methodology used for the design of the filter is the insertion loss method, which consists out of the filter specifications, the prototype design, scaling and conversion, and then the implementation of the transmission lines. The transmission line stubs were implemented to have a second order equal ripple response. The normalized characteristics were then converted to transmission line stubs using the Richards transformation. Garuda identities were then used to attain a more practical implementation of the transmission line stubs. And to implement the system, a combination of microstrip and coaxial cables were used to model the transmission line stubs in order to give a high pass or a low pass response. In terms of the operation of the system was tested by connecting the following components. These components are the signal generator, which provided the circuit with a sinusoidal response. This was connected to the 50 ohm coaxial cable, which is connected to the BNC connector, which was on the low pass and the high pass microstrip. These microstrips were then connected on the other side to the BNC connector, the lowered coaxial cable, which is also 50 ohm, and then the oscilloscope, which measured the output response of the circuit. The summary of my learning during this project was how to divide the project into different milestones. It is important to divide a project into manageable phases in order to complete a project. I had to learn how to adapt to challenges as they occur, such as, for example, when the oscilloscopes in the lab didn't have a big enough bandwidth to be able to measure the circuit, to be able to measure the transmission lines. I made use of standard software in order to model the substrate and of the microstrip, as well as the coaxial cable, in order to using the parameters of the built of the fabricated substrate and connect it to its coaxial cables in order to find the correct low pass and high pass response for the system. I also learned how to better keep track of when each milestone is due by setting up a calendar and then marking down when it went down when every milestone is due. During this project, I also learned how to come up with more innovative solutions, like how by using the standard software, I learned to, when one solution doesn't work, try another one in order to get the project completed. Thank you very much for your time.